put it in the death. Come on. This Newton, not my guy for this stuff. Okay, like this thing. This thing, 4 pi r squared r prime. That's like kind of janky. Okay, that's like not as good. You should be using this Lebanese notation. But that's essentially like kind of like the y prime stuff you were doing earlier. So then what you're going to do is you're just going to make it look nice. So I need to find a function that represents the change in volume. Well, actually, that's just it, isn't it? There you go. Right there. So that's it. You just take the derivative. That's the answer. That's the equation. We're going to be plugging in numbers later. Okay? Yeah. All right. Do you remember this? Oh, this was like before you guys. Right? You're little. Okay. But this was a huge deal. Okay? There was an oil spill, okay, in the ocean. Or nope, just kidding, Gulf of Mexico. It's spread in a circular path around the ship. Derive a function that represents the change in the radius. Guys, stop talking, please. Change in radius of the oil spill with respect to time. Okay, so you have to somehow come up with an equation that's going to relate all the things happening here. So if you notice, this looks like something, doesn't it? You know. Okay, it's a circle. Okay, so I need to somehow talk about circle and radius. Okay. Actually, you could technically do circumference with this, but I'm going to do area. So if I did area, what's the area of a circle? Pi r squared. Yep. Pi r squared. If you, well, I'll show you in a sec. It's cool. Okay, and now what you're going to do is take the derivative of it. So you're going to do the derivative of a with respect to time. dA dt. Does anyone recognize this formula? 2 pi r. Does anyone recognize that? Oh my gosh. Calculus can be so cool. You don't even know yet. It's so exciting. And then you're doing chain. Okay. Now I need to write a function that represents the change in the radius of the oil spill. So for this one to find the change in the radius, change means I want the derivative. So I need this guy over here. Usually the notation for this is write it as 1 over 2 pi r times dA dt equals dr dt. Instead of like putting the derivative like on the like putting the 2 pi r divided by, that just is kind of like not as nice of notation. Okay? So there you go. Hey, hey. So those are kind of nice. Okay. This one, here we have planes. 2 small planes approach an airport, one flying due west, other due north. Assume they fly at the same constant elevation. Write a function that represents the change in distance between the planes over time. Okay, so what's happening, it's hard to see on yours, right, with the arrows? Yeah. But notice that this plane is going this direction. Okay. And then this plane is going this direction as well. So they're going to the airport. And think about as the planes are moving, the distance between them is also changing. That's probably going to get shorter or longer. What do you think? As time goes on, is that going to get shorter or longer? Shorter, right? Okay, so we need to somehow come up with an equation that can relate all of those variables. So, what do you think? What's an equation in your arsenal that relates all those things? A little Pythagorean theorem, remember? Remember Pythag? Okay, so we're going to have x squared plus y squared equals, I'm going to use z, kind of hate z's, but that's okay, z squared. Okay? Okay? Nah. Because then we don't have we need the hypotenuse. Oh, No. Okay, so we want a function that represents the change in distance between the planes. So that's going to end up being z, but I'm going to first do a derivative. So I'm going to go 2x times dx dt plus 2y times dy dt. I'm feeling different colors today. And then 2z times dz dt. So 3 different rates that we're going to have to do. Now, here's the kicker, okay, is, you know how like what was that, the robotic book, textbook, do you remember that problem? It was going like left or right, okay? What you want to pay attention to is when these derivatives are positive or negative. So like the ones we've been doing, these other two, this was strictly increasing these rates because the oil spill was getting bigger. The balloons were getting bigger, okay? Whereas on this one, if you think about it, okay, now this one doesn't end up mathematically not as like super necessary, but like if you look at this x here, this value, that length as time goes on is getting smaller because it's going this way. So as time is going on, you need to recognize that that dx dt is going to be a negative number, okay? So for this one, that's a negative. Then you're going to look at y, okay? Y over time gets smaller. Now, some people are like, it's going up. Up is positive. No, okay? It's all about the distance, if it's getting smaller or not. So this distance is also getting smaller, okay? So that also needs to be a negative on it, okay? And then if you were solving this problem, once we get to that, dz dt, you know you're doing it right if you get a negative answer. Because if you're kind of thinking about it, right, if both of those are getting smaller, the distance between them are getting smaller. Okay, so what you're going to do now is you're going to solve for that dz dt. I'm actually going to divide out all the negative, or the 2's. I'm going to get rid of all the 2's. So I'm going to go negative x dx dt, and then I'm going to do negative y dy dt, and then I get z dz dt. So then solving for dz dt, I would get, just to make it look nicer, I'm going to write this as 1 over z times all this. Negative x dx dt minus y dy dt. And then that'll be your answer. Whee! And then we'll plug in numbers later. It'll be fun. You'll have to do some Pythagorean theorems, all these fun things. It'll be cool. The hardest part is coming up with the equation to start, because they just give you some random stuff and you have to like relate them all somehow. Okay. Same with this guy. Casual Saturday, you know, I stood 200 meters from a launch site of a hot air balloon recording. Mr. Jordan was doing that. And I was in the air. Yeah, I took a TikTok, hey? Went viral. Okay, as the balloon rises vertically, the angle of elevation is increasing. Write a function that represents the change in height of the balloon over time. Okay, so we've got the balloon. We've got an angle of elevation. So we've got an angle. Okay, we're told there's a 200 meters from the launch pad. I'm not moving, or he's not moving. And then I'm going up in the air, right? But that's changing. So everything that's changing is getting a variable. Okay, so y is changing because it's going up. This angle's changing because it's going up, but Mr. Jordan's staying, so he's not moving. So the 200 is going to stay where it is. So everything that's moving is going to get a variable. Now I have to somehow relate all that junk. And you just pull this out of your head. Does anybody know? How do you relate all those things? The red, the blue, and the green. SOHCAHTOA. TOA. Hey? TOA? Tangent? Tangent relates it all. Okay? So that's what's hard, is you have to somehow like pull that out of your brain. So you have to be like, oh, tangent of theta equals opposite over adjacent. And again, I can put in the 200 because 200's not changing. Mr. Jordan's not moving towards the launch site. So because he's staying there, 200's not changing. All the stuff that's changing needs to have a variable for it, so you can do chain rule. So now you're going to do a quick deriv. Ready? Because I want to make sure you know these. You have to study them if you don't know them already. Okay. You gotta chain everything.
It's not that. It's not that.
No, well, you have to chain the theta and chain the y.
Oh, this is quotient.
No.
No. What?
Got to chain all the variables. Well, this would just be 1 over 200, right? Times y.
What?
Because this is the same thing as 1 over 200. It's like y divided by 2 is the same thing as 1/2.
Oh.
No. And then this would be, you have to do chain on the theta. So you have a d theta dt. Yeah, no. Because this is the same as 1 over 200 times y. Or maybe here. I think we're getting mixed weird with the fraction. I'll show you. So if you take the derivative of tangent, you get secant squared. But you have to do chain rule on the theta. So d theta dt. Okay. Then this thing, I don't know if this helps. Maybe think of it as tangent of theta of 1 over 200 times y. How about that? Does that make you feel better? So if you take the derivative of this, you get 1 over 200, and then times chain dy dt. So every variable needs a d theta dt or dy dt. If it's an x, you do dx dt. If it's a, I don't know. Okay, so every variable has your chain on it, aka your little sneaky chain, aka your implicit differentiation. And then what I did is multiplied over the 200 because they wanted the change in height over time. Any questions on that? Okay. And then last but not least, the ladder. Infamous ladder problem. 13-foot ladder is leaning against the vertical wall when Robbie begins pulling the foot of the ladder away from the wall. Write a function that represents how fast the top of the ladder is sliding down the wall. Okay, so what do we have? We have a 13-foot ladder. Is that changing? No. Okay, we're doing the OG ladder. Okay, so that's not changing. 13 is leaning against the vertical wall when Robbie begins pulling the foot of the ladder away from the wall. So what's going on? This length is changing and it's going down, right? And then this length is also changing, but it's increasing, correct? So we somehow have to relate all these things. I'm going to let this be not blue. Ew. I'm going to use Y because it's up and down. Groundbreaking. Okay. This one, kind of side to side, I guess. Okay, how do I relate all that? What formula from my math knowledge? Yeah, this is another Pythag. Okay, so you're going to be doing, you got x squared plus y squared equals, now I can put 13 in because it's not moving, right? So that's not moving. So what I'm going to do is I'm going to do a derivative. So 2x and then chain dx dt plus 2y times dy dt equals 169. No.
No.
0.
Oh.
Derivative of a constant is 0. People are going to 26. Yeah, people do 26. And I'm like, oh, geez, Louise. And I'm messing something up. Something's messed up. It's got to be a negative. Where? On the y. The reason is because this length is getting smaller. Whereas on x is increasing. So that's going to be positive. So this rate of change is negative. Okay, why do I even need to find? Write a function that represents how fast the top of the ladder is sliding down. Okay, so that's like what? Y, right? Yeah. Okay, so then you just solve for that. I'll just do this. Yeah, and I don't want to deal with 2's. Let's get rid of 2's. So that'd be x dx dt equals y dy dt. And then we need, what did we do again? Dy dt, right? Yeah. So I need the y's out of there. So dy dt is x over y times dx dt. And there you go. And that is all we got. And we've got a worksheet.
Good. So we're just finding inflation.